We're helping businesses across Asia Pacific to drive innovative transformation. HSBC believes smarter banking paves the way to a smarter business.
Thank you very much. So is it loud enough? You hear me? Can you put up the volume a little bit? Okay, thank you. Yeah, my name is Eberhard Schöneburg. I'm not here the first time at FinTech Week. I'm giving these presentations pretty much for the last six or 7 years. And what I'm always trying to do is I'm not giving you a sales representation or presentation, but I try to give you a little bit more of an outlook in what direction certain technologies will head. And I also give some warnings, some criticism, try to be neutral about the whole subject, but give you an idea what's coming up maybe in the next couple of years. So I'll be talking essentially about these topics. That is, what actually is the Metaverse? We heard just from the moderator typical classification of the Metaverse, some exciting 3D world and so on. But I will also talk about AI, how it's related to the Metaverse. I think that is one of the most profound and important cooperations, AI and Metaverse, the technology, the basis on it, and the applications in that field. But then where it gets really interesting in my eyes is my theory is that the Metaverse as we know it now, and as you can see it when you go out and watch what's presented, you see the people with the goggles on and you see some 3D world, that this will disappear pretty much soon. It's a fad. It's not what creates the value of the Metaverse. What will happen, it will disappear, and the Metaverse will literally get sucked into your brain, into your body. And this is mostly what I will be speaking about. And then also where this could lead and how do we go on from there, what's coming next. And also a little bit scary outlook at the very end when I go more into generating new brains, literally new brains, not just emulating, simulating brains and intelligence, but creating brains. So for myself, I don't want to talk too much about myself, but what is important though is that I have been working in this whole field of AI and Metaverse pretty much from the beginning for over 40 years now, and even Metaverse. So when I prepared that, I looked back at all the stuff that I have done in this field, and I'll, just for the fun of it, show you some of the things that I have been doing 30 years ago relating to the Metaverse. Right now, I have no company. I have a think tank, cognitive systems lab all around the world. We're working on some very advanced futuristic themes, not only AI, but what comes after AI, beyond AI, and something which I call alternative AI. And besides that, I have some advisory positions in finance companies and so on. So, as I said, I did some study of what I have been doing, and I found some old stuff. Sorry for the quality of this picture. When I made this, you can see 1996 was the first commercial available shopping mall online in Europe. At that time, it sold 150,000 products already at that time. That was something, because you may remember the internet and the browsers were just invented at that time. So we had the first commercial browsers, and very early on we built this. But what's cool about this, and why do I relate this to the Metaverse, is what you cannot really identify there, I guess. These are sky-rise buildings. And every building has layers of brands. And what you could do in this world, it was called My World, was individualized shopping. You could build your own shopping mall, shopping area with different brands, with different shops. So pretty much what you see in 3D Metaverse systems today. And then I actually created the first real Metaverse, as you can see here, but it's funny, right? 30 years ago, how the avatars looked like. You can see here on the right side as one of the cities of this world called Avataria. Avataria was the capital of the world, and the world was called Octerra, which means the eighth continent. But what is interesting is if you look at this in the middle, it's a little bit futuristic, utopic kind of design layout. It was a circular city with different regions of the city that were dedicated to certain different areas, like entertainment area on the left side and so on and so on. So if you fast forward this to what Meta is doing now, the avatars don't look so much different, don't they? So, and then things got a little bit more interesting, more commercial. So we went from bots and avatars, which I have created most of the basis technology. We created so-called the first robo-advisors. So look at this as a robot-advisor in 1998. So this is what, 24 years ago. And it was a portfolio manager, portfolio assistant. And it was not even just one of these avatars or bots. We had a whole set of bots that communicated with each other. And the layout and design of this is down there. And I also filed for a patent to have the speech interface with these bots. So you could, at that time, type anything in any given natural language, but you had to type it, you couldn't speak. And just at that time, when I draw this slide, we had the first speech input systems attached to it. And then, 2001 was the big collapse of the internet bubble. And we had a problem. We thought, now we have all these bots, these finance bots, but nothing really happened anymore. The banks did not fund or finance any projects related to bots. It was all over. The whole internet boom was over. So we thought, what do we do? And at that time, the first versions of smartphones came up. So we switched from banking finance applications of bots to gaming applications of bots. And I developed the first virtual girlfriend. This got a crazy cover. We were front page, New York Times, Washington Post, and everything. And it was actually a very smart game. As you can see, the graphics still very, very simple. And you can also see a very interesting trend, right? 2003 is the upper line, and then down there, that's 2007, 2008, the first version for the iPhone. You see the sexing up, right? That was the cultural switch from Hong Kong to an American platform. But what was interesting about that is that this girlfriend was a real character, so real base AI in it, in the sense that you had to please your girlfriend. You had to give her presents, and you had to do all kinds of things, be nice to her. If you were speaking to her in a not so nice way, she would be blocking the conversation with you. She wouldn't speak to you. If you may recall, there was a game called Tamagotchi at around this time, a little bit earlier in Japan, where you had like a virtual dog you had to take care of. So I don't want to compare the girlfriend to a dog, but the gameplay, the situation was very similar. So then came a real breakthrough with Second Life. So I was not involved in Second Life. This is the first real metaverse in my eyes. It had an economy, it had a currency, a dollar that you could convert. You could buy properties, all the stuff that you see now with Web3 and Bitcoin and all these other things that you can use, cryptocurrencies. This was very, very advanced and is still alive today, but it's not noticeable anymore anywhere, really. But that was the real first metaverse, I would call it. And then what we did is, again, we did the first mobile metaverse. As I said, so that the iPhone was introduced around 2008. In 2010, we released this really first massive mobile multiplayer community with the famous rock band Linkin Park. It was one of the coolest projects we've ever done. And that was also a real and intense metaverse. And you can see here, the graphics were already much better. The characters were still pixelated, but that was on purpose. We didn't have to, but it was part of the game. The pixelated characters were kind of the underground fighters. They were fighting a dictatorship, and you try to combine with other players to find the dictatorship, and so on and so on. And you can see on the upper right side, it had different areas, and on the lower left side, you had all these meeting places where you could meet, and so on. And again, I want to point out, this is 2010. And the best performance at that time that we could get, we had millions of users, but only around, in the maximum performance, around 30,000 concurrent users. But still, that was really, really a big achievement at that time. And now, today, yes, this is how it looks like. No much progress in my eyes on the graphics and visual side. It's the whole problem is the scale now, right? Because you have not 20, 30,000 users, but potentially millions of users or hundreds of millions of users. So the graphics have to be cut down again back to the very primitive pixelated style, or the avatars, the famous avatars of Meta, they have no legs, right, to make the stuff easier. So, but now the key points that you see also when you walk around here is these new interfaces, cool new interfaces, I have to say, a lot of them, like you see it on the left side, a combination VR, AR, XR, all together with this 3D world. And what I'm working on, and I will talk about more interesting, is if you even go further, so you have this goggle, but this is not just a normal goggle. This uses your brain functions as well. That's why it has a set that covers your back of the head and not just your eyes, and it measures your brain signals in real time. So I'm going to talk about this in more detail and where it's heading. So because this is just the beginning, I want to talk about what comes actually when you can do that, what comes next. So as I said, I'm essentially an AI expert, and I want to talk about how the AI will change the metaverse, will enhance the metaverse, but also in a sense will kill the metaverse. And there are some very, very interesting developments going on right now, and I will talk just about a few of them. So one of the key points that I see right now after so many years is this dramatic breakthrough in the processing of language, especially natural language. So if you look back over the last couple of decades, every decade had kind of their special focus on certain AI technologies, from expert systems to neural networks to genetic and evolution theories, rule-based systems, or stuff like this. But this decade, 2020 to 2030, in my eyes, is mostly, or in hindsight, will be seen as the language decade of AI, because the breakthroughs that we have right now are dramatic. And this will influence especially also the metaverse developments. So we have now a situation where we have these so-called large language models. These are extremely powerful processing systems that can read great amount of text, the whole internet, for example, as input. And what you then do is you process these inputs in a certain way, pre-process, and then use neural networks attached to it. I get into this a little bit more in detail. What I expect is that the so-called Turing test, that usually is seen as a measure of intelligence, and for some really the defining measurement for intelligence is if you can pretend as a machine to be a human and no human can detect the difference, then you have to admit that this system is intelligent in some sense. So I predict that the Turing test will be solved. Solved means that you can talk to the system for a while, maybe a half an hour, maybe an hour, and at the end, you do not know whether you spoke to a machine or to a human. I'm 100% sure that this will happen. And that will be a dramatic breakthrough, similar, comparable to when the computer managed to handle the Go game or chess game, something like that, a major milestone in the industry. Another big thing is that we were always assuming that machine may be able to think in a very logical, very precise way, but it may never be creative. Creative was considered to be a part of the human genes. We are the creative people, but it is actually not the case. I show you some example of astonishing creativity completely produced and generated by AI. We will have in the future the ability to talk to a computer system and just tell the computer system, oh, I want this and that, can you create this for me? And it will happen, and I show you some examples. And the most critical part, in my eyes, the most dangerous part is, but something that happens already everywhere, is that you have to develop and define AI systems that enhance themselves. It is way too complicated and too much effort to fine-tune and optimize every single AI system. First of all, there's millions out there very soon, and then every AI problem has a different solution. So you need to automate that process. We will have systems that can enhance and improve themselves, and this is a major dramatic thing to come up as well, and it's also based on the language revolution stuff. And it entails also the ability to automatically generate programs and automate the coding process, the writing of code. And the final step in my eyes is we will go from natural language processing, natural language training, understanding, to brain language processing and brain language understanding. And what this means, I will explain. So I spoke about these large language models. All these big players that you all know in the AI field, they're all working on these so-called large language models. As I said, what these are just dramatic, huge clusters of computer systems with distributed AI that process language and especially process all the input of language that these systems can get. And it's not just the language. The good systems, they will combine language and pictures and sound and all kind of input they can get to train the systems. And this brings them a level of power that we have never seen before. And the real problem with this is that training these systems, building these systems, and running these systems is extremely expensive. You cannot have a laptop or a small cluster of laptops to run these systems. Training one of these big language models costs in the millions of dollars. And you need huge server farms. That is also the reason why all of these companies are companies themselves that either sell server services, produce server services, produce special hardware, or all kind of distributed processes. So they're even able to do all that. As a small company or even as an individual, you have no chance to build or to train a system like this. And that is a very dangerous development in my eyes, because it means we will soon have, or already have, if you look at this, kind of monopoly and domination of a few, only a handful of companies. And what you can see here are a few numbers. The current systems that are in the range on the upper right side have about 530 or around half a trillion parameters, half a trillion that they have to adjust in any training run. What that means is, for each of these training runs, if you have a half a trillion processing units, you need at least around 10 to 20 trillion training examples. So that's the other real big bottleneck. You cannot just train them on a few pictures or so. You literally need a trillion pictures to train these systems, or text sequences to make them work. But some of the results are already now shocking. You can give a human-oriented IQ test to these large language models. Not full tests yet, but major chunks of it. And in general, they will outperform humans the average human, so to say, on an IQ test for humans. And that is just the beginning. So as we see now that no human can beat the AlphaGo anymore, we will soon have that no human can beat any of these large language models in any IQ test. Yeah, I speak about the impact on the metaverse now, which is the key point for you when you think about the metaverse. So we are here at the Web3 stage, right? So the whole idea of the Web3 is that, or the supporting argument for Web3 is that you have intellectual property in a controlled way, you can transfer value, and most important, that is why these metaverses are so interesting, you can actually make money by producing virtual objects, and we had now the government of Hong Kong agreeing to be able to trade it in a controlled environment, these virtual objects, not just currencies, but you can trade virtual buildings or whatever you want to build in such a metaverse. But you assume you can make money because you will own it. But if you want to own it, you have to produce it, and you have to produce it in a certain certified way, right, on the blockchain, and so on and so on. However, with these natural language models that we are having now, you can automate this whole process. You can pretty much produce anything digital in a metaverse just by saying, I want this and that. Build me a house, or do this and that, or build a shopping mall with these and these features. And the system will do this automatically. And that means the whole idea of having the Web3 for people to make money by building, trading, and dealing with virtual objects will probably fade away because it will all be done by machines. So the owners of these virtual properties are the ones that run and own these machines that produce these virtual objects. It will not be the artist or an individual that will make a lot of money in this metaverse. So this is a downturn, I would say. And here are some examples. You may have all heard about DALL-E 2, for example, or DALL-E. This is a language system where you can just say, create a picture of a robot that looks like an insect, and something like this comes out. Or you can be very vague. You can just say, create some art piece with certain features. And you can be very vague with the features too. You can say, make a picture of an astronaut on a horse or something like that, right? But you can also say, make Mona Lisa look a little bit strange or very modern or like a punk or something like this. Or you see, draw pictures like Salvador Dali and so on and so on. All of this just with a very short instruction like do this and that, and everything else afterwards will be completely automated. So that means, there will be a very, very small niche for artists left over, right? And it's not just that it combines some pictures, it really literally generates completely new pictures that no one has ever seen or drawn or even had an idea how something could look like that. So you can use this for design purposes, for buildings, for anything. It comes up with a completely new architecture or design. And you can go a step further. There are already systems that don't just produce still images, but they produce sequences of images. So literally they produce movies, video clips. Right now they're usually short, like TikTok type of video clips, right? A couple of seconds. But there is no general problem at all besides computing time, computing power, to say, produce a movie with an actor that does this and this. And everything else will be completely automated. It is insane if you think about this, right? The whole movie industry will get in real trouble once this really works well. And this is one of the areas that I'm mostly impressed about. What happens is now that some companies like Microsoft, they already use these language models to automate or partially automate the generation of code and programs. So you can, if you want to write a complicated function, you can say, write a function that is doing this and that. And with a little bit of luck, the system can do this completely, or at least it can help you. It can reduce the development effort and amount in a dramatic way. And if you think through what this means is you can essentially build autonomous agents very soon that do stuff for you on the metaverse or wherever it is without interfering, and you just describe to that agent in a very short phrase what you want the agent to do. It is like you deal with a human, right? If you have a secretary or you have a child or something, you say, go buy some milk or so, right? You don't have to describe, like in the program, what exactly to do, in what sequence, and so on and so on. The system will figure this out, handle it, and then even execute that task. This will have a dramatic consequence. It will also help, in my eyes, to make the standard 3D metaverse, as you think about, disappear. What you will have in the future is you will have robots that work for you, I mean virtual robots, software, that work for you, that do things without you even noticing. You just tell them what to do, and they may come back to you and talk to you. And I think when that sounds close to smart contracts for you, it is essentially, that's what it is. You combine these large language models with the smart contract technology, you get kind of a DAO that is driven by these smart contracts and these language models. So this is a very, very interesting development and will give rise what I would call to a roboverse. Instead of the metaverse, you have a roboverse that is full of robots, virtual robots, and they even communicate with they trade with each other, they do all kinds of things with you, and you are not even bothered. It will be all pretty much automated. So the next really big step in my eyes, and I said this in the beginning, is what I see coming essentially is another reason why the metaverse, as you see it outside there and all these computers, is that it will get sucked into your brain, literally. And for that, there's a certain area under development now, of which I'm also a big part, is so-called brain-computer interfaces, right? So you use a direct link of the brain to a computer or any IoT device, essentially, that has some processing capabilities. And as you can see here in this chart, there's all kinds of ways in which your body and your brain can communicate with the outside world, because most of it is driven and works through electricity. Your brain works through electricity, and even your muscles and the skin and everything, when it communicates, uses bioelectricity. And you can use that for communication, for executing processes, and so on and so on. You can actually use the whole body as a data network. You can transfer data from the right hand to your left hand, just using the skin conductancy for electricity. So this is a trivial thing. Everybody knows that when you have a bit of physics background. But what is obviously more difficult is how do we access the brain? So there's two ways of doing it, right? One is intrusive and the other one is non-intrusive. Intrusive means you literally make a hole in the head and you put a chip inside. This is the approach of Elon Musk, essentially. Or the other way is so-called non-intrusive. That is, you need some kind of an outside device that can detect the activities of the brain through the skull without penetrating the skull. This is called so-called non-intrusive activities. And as I said, you can use the skin for all kind of processing. And Elon Musk, because of him, I think this thing gets so much attention now, which is good for the industry. It may not be good for Elon Musk because he hasn't been really successful. He spent a couple of $100 million, and he hasn't produced anything new yet in that whole field. I think he underestimated a little bit the difficulties that we have there. So, and then already in the 1990s, researchers have figured out how you can use the brain to literally control devices just by thinking, just by brain activity. And this was first done with rodents, then with monkeys, as you can see here. So they were trained of moving a certain lever, and then when they did it right, they got some reward. So they learned very quickly to do the movements, and then they had to do the same task, but they took the lever away. So he just had to think that he's doing this movement with his hand, and it works very, very, very well. And monkeys can easily do that. They can do very complicated things just by thinking about certain activities. And we have then used this in all kinds of applications already. You can now control a person that is paraplegic or so, cannot move, can use the brain to control a robot, or the person on the left, for example, had an accident, lost their limbs. They can control the limbs through an electronic interface just by thinking. And this has now gone so far down that you have even a lot of toys you can play with. And even, sorry, go back. You can even do applications where people work together or against each other. I'll show how this works later. We have now very, very sophisticated brain-computer interfaces where you don't need to drill any holes or it, but these are combining very complex different technologies. So you're not only measuring the electrical activities, you're also using ultrasound and all kinds of things, infrared light, for example, they have an extremely high resolution, not down to individual nerve cells, but to very small clusters of nerve cells. So the higher the resolution, the more you can do and the more concrete and specific you can get with these activities. So now, when you can use your brain to control a device, the next step actually is even more interesting. You can introduce telepathy. You can literally communicate with another person without talking to them or without looking at them, being at completely different places, and just have the brains communicate with each other. So the typical approach, what you do here is one technical chart, sorry for that, but it's very simple. You just get a stimulus to one person. A person sees something on a screen, for example, and then the brain signal is recorded, is sent to the other person's computer, and there the computer produces a signal that causes the person to do something. That is a fact that we know already for hundreds of years, that if you have a frog and you attach an electric charge to a frog leg, the leg will move, right? So you can execute movement or activities of the brain by giving a very, very small electrical charge. And you can use that effect either with electrical charge or magnetic charges to make a person have certain experiences in their brain. And what you can see here, this is, for example, two people playing a game with each other over a big distance just by thinking about playing the game. Here you can play Pong, for example, two people sitting next to each other, playing with each other just by thinking, not using a mouse or anything in their hands, and not even using any goggles or anything. And then what you can do is, where it gets really interesting for businesses, you can actually hook up many brains and make them do or solve one big task. You know, we all know that every individual brain is limited, but if we combine brains, you know, in meetings, or if we work together at universities or wherever, we get a big output, right? Because we work together and everybody has strengths and weaknesses. We can do this now on the brain level. We can actually combine the signals of brains so that they can solve one task that the individuals that are participating cannot solve themselves on their own. And this has been done. Has extremely interesting applications. As you can see here, you have three people that's solving the Tetris game. You know the Tetris game where the bricks fall down, you have to turn them around. They can solve this just by thinking when everyone can turn the brick around only in a certain direction. And then the next step is these brains, when you hook them up and you connect them, they can actually synchronize. That is a very, very interesting fact that is already known for a long time between mothers and their children. It can be measured, for example, that if a mother has a young child and holds the child, then the brains will synchronize, the brain of the child and the mother's brain. It will work in the same frequency, and with the same regions of the brains will get activated. You can use this now in a technical sense that these brains synchronize themselves. It's like you have different computers that have different speeds and do different things, but if you let them run together, over time they synchronize and they work on the same thing together as a unit. So you merge, you melt brains. It's called brain melting. Now, to end this up, some still very, very interesting things that you might not expect in a session like this. I don't know if you ever heard about these Hogan twins, but they're very famous for a reason. So first of all, twins that are not really separated are very rare. It's 1 in 2 or so million twins have this effect, this burst effect. But even more astonishing and interesting is that they have an additional effect, namely their brains inside are connected in a certain area. You can see this area in the middle. So they have 2 separate brains, completely separate brains, but in some areas they are connected. They grow together during the pregnancy. And what this has as an effect is unbelievable. So there are 2 completely different personalities, right? The 2 girls, one is more aggressive, one is softer, one is more stingy, the other one is more generous, and so on. They're really completely different characters. But what they can do is, for example, you can close the eye of one of these kids and show the other kid a picture. And then the kid whose eyes is closed can see the picture. You can also, the kid on the right side can move the arm of the girl on the left side, and so on and so on. So when I saw this the first time, it was around 2010, I got shocked and said, this is it. This is it. This is the future of the metaverse. If I can exchange everything that some other person experiences, and I can kind of go inside that person without being inside, right? That is the trick, obviously. But what we can do here is we can emulate that bridge between the 2 brains, and we can then have the same effect. So the idea is you create something that allows you to experience the experience of another person, and back and forth. If that were possible, imagine that. So what we can do now already is we can literally see what other people are seeing. So there's these experiments where you show someone a picture and you generate the brain activities, or you record the brain activities when the person sees that picture. And then you have a researcher who knows how all this works, and he only looks at the data that is generated from the brain. He doesn't know what the picture is, but he can still tell what the other person is seeing. So it's pretty much at the same level as the 2 girls. You can look inside the brain, in a sense. And you can see here the output. On the upper row is the original pictures that the person sees. On the bottom are different variations of what the computer has reconstructed just from the brain data. And obviously you can see this is not perfect, but we're getting there. Right? It's a matter of the resolution. And you can see here, in some areas, for example, for detecting the lines, it's nearly as good as any computer algorithm already. We can detect this. And in the language area, to wrap up with the language ideas, we can even now detect in the brain the semantic areas. We can tell if someone thinks about something, let's say his family, or his finances, his business, or his vacation, or anything. We know where he thinks these things. So which areas of the brain are related to these kinds of concepts and the semantics. So if you look at the picture, for example, like on the left side, we immediately don't just see a picture, right? We see high-rises, we see a beach, we see a guy with a surfboard, and so on and so on. And we think about this, right? We don't just see a blob of colors. We see sky, we see clouds, and so on and so on. And these things are represented in the brain. So we can, if someone looks at the picture, we can actually identify what they are thinking about the picture. And coming to the end now is, so even there is not the end yet. What happens now is, and I'm involved in some of these activities as well, is that we can actually actively influence what the brain is doing and what it is perceiving. So we can actually implant things in the brain that you perceive which is not there. So we can make you think you see something, but that what you see is not there. It's fake. It's like a fata morgana. So it can be implanted, and has been done with mice. Obviously with humans, you will be very, very careful doing these kind of experiments. But think about traumatized people that had a really bad experience, like a woman maybe got raped or something like that, or a soldier in a war, he saw some really dramatic bad things. So how can you make that person forget this, right? So you don't want to destroy the brain, obviously. That would be an overkill, right, in the literal sense of the way. But it would be cool if you could override these really bad memories with new and good memories. Stuff like that, for example, is on the way, is been doing. And what we can also do now is we can enhance and augment brains. So we can give you new senses. As I explained just before, that you can kind of experience what other people are experiencing, we can do even more. We can give you new senses. For example, what you see here is a mouse. Mice have the same vision system as we. We cannot see infrared light, right? That is where our visual system stops. But you can train a mouse to see infrared light, and you can, in that way, augment the brain. So the brain can suddenly do things it was never able to do before, or no other human was able to do before. And what we can do now also is we can actually create completely new types of brains. We can grow now brain tissue outside of a human body, so for example, human brain, and then we create like very, very small mini brains. But they are literally like brains. They have the brain signals and everything, but we can grow them outside of the brain, outside of the body, and then we can combine these different kind of mini brains to one new brain and create kind of a brain-based computing device that has no hardware in it, no chips, no electronic devices or anything like that. So I think for most of you this might be a little bit scary. I understand that, but I'm here to not push a technology. I want to speak about what is possible and what may come up in the future, and this is where it goes. Thank you very much for your attention.